When you click send on a digital payment, have you ever stopped to think about what's really going on behind the scenes? It feels like magic, right? Well, today, we're going to pull back the curtain on that process. We're going on a little journey to figure it all out. And in doing so, we're going to get a handle on one of the most talked about technologies today, the blockchain. Okay, let's dive in.
So, let's start with that big question. We're going to follow a single, simple transaction from the very beginning all the way to the end. And trust me, by understanding its path, we're going to see how this incredible system of trust can be built, all without a single bank or big company in the middle.
All right, first things first. Before we go on our journey, we need to get our heads around the core idea. What even is this thing we call a blockchain?
At its heart, it's actually pretty simple. It's a digital ledger. Think of an accounting book or even just a spreadsheet. But here's where the magic comes in, with 3 key ideas. First, it's distributed, which means everyone has a copy. Second, transactions are all bundled up into blocks. And third, those blocks are cryptographically linked together, creating a chain that is, for all intents and purposes, unbreakable.
And all of this leads to some really powerful principles. Because it's decentralized, no one person or company is in charge. Because it's all linked up with math, it's immutable. You just can't go back and secretly change the past. It's transparent for everyone to see, it's incredibly secure, and maybe most important of all, the entire network has a way to agree on what's true, all without needing a middleman.
So let's start that journey. We're going to follow a single transaction from the very first spark, the moment it's created. Okay, so meet our cast of characters, Rem and Maher. Rem wants to send 50 digital tokens over to Maher. This one simple action is what kicks this whole incredible process off.
Now here's the thing you've got to understand about a digital wallet. RIM doesn't have a digital box full of coins. A wallet is really more like a keychain. It doesn't actually hold your stuff, it holds the secret keys that give you control over your stuff.
And on that keychain, you've got 2 super important keys. The private key is your biggest secret. Seriously, think of it like your own personal handwritten signature. You use it to sign and approve any transaction, proving it was really you. Then you have the public key. This is like your bank account number. You can give it out to anyone, like Maher, so they know where to send you things. It lets the network check your signature without ever seeing your secret key. Pretty clever, right?
Okay, so Rem has signed her transaction. What's next? Well, she doesn't send it to some central bank server. She sends it to, well, everyone. And this is where things get really interesting, as the transaction joins this global shared ledger.
Her wallet literally just broadcasts that signed transaction. Reem sends 50 tokens to Maher out to this huge global network of computers. We call these computers nodes, and every single one of them is helping to maintain the ledger.
There's a great analogy for this. Imagine a small village where everyone keeps their own copy of a shared accounting book. When one villager pays another, everybody sees it and they all write it down in their own book. Now, no one can go back and secretly erase that payment because everyone else's book would prove them wrong. That's a distributed ledger, in a nutshell.
Okay, but this brings up a huge question, right? If everyone has their own copy of the book and there's no mayor in charge, how do they all stay in sync? How on earth do they all agree on what the truth is? Well, this is where the real magic of consensus comes in.
Think about it. What stops Rem from sending those 50 tokens to Maher and then immediately sending the exact same 50 tokens to someone else before the network figures it out? That's what we call double spending, and it's the #1 problem that these consensus rules were designed to solve.
So how does the network agree? They use a set of rules called a consensus mechanism. Take proof of work. That's what Bitcoin uses. Computers, or miners, basically compete to solve a really hard math puzzle. It's incredibly secure, but, as you've probably heard, it uses a ton of energy. Then you've got proof of stake. Here, people stake, or lock up, their own coins for a chance to be picked to validate transactions. It's way more energy efficient. And then there are others, like delegated proof of stake, that try to be super fast by letting people vote for a small group of pros to do the validating. Each one has its own trade-offs, right? A constant balancing act between security, speed, and how decentralized it is.
All right, so the network has agreed RIM's transaction is legit. Now what? It's time for the final, most important step, adding it to the permanent, unchangeable record. This is where the block and the chain finally come together.
So REM's transaction doesn't just get added all by itself. It gets bundled together with a whole bunch of other recent, valid transactions into a big list. And that list is what we call a block.
Now, to lock this block down, the network uses something called a hash function. It's a cool mathematical trick that can take any amount of data, like all the text in that block, and crunch it down into a unique, one-of-a-kind string of characters. That's the hash. And check this out. Just changing one tiny thing, like making one letter lowercase, creates a completely different hash. It's basically a perfect digital fingerprint for that data.
And here is the truly brilliant part. When a new block is created, it includes the unique hash, the digital fingerprint, of the block that came right before it.
By doing this, by linking each new block to the fingerprint of the last one, well, that is what creates the chain. It's not just a cool name. It's a literal cryptographic connection.
And this visual really shows you why it's so secure. If someone tried to go back and change a transaction in, say, block 1, the hash of block 1 would completely change. And that would instantly break the link to block 2 because block 2 is looking for the original hash. That would cause a domino effect, breaking every single link down the line. The network would immediately know something was wrong and reject it. It's like digital cement.
Whew. Okay, so we've followed Rem's transaction from her wallet all the way onto this permanent, unchangeable chain. So let's zoom out and ask the big question. Why does any of this matter? Why is this so revolutionary?
So let's do a quick recap of that whole journey. 1. Rem creates and signs the transaction. 2. It's broadcast to the whole network. 3. The nodes check it out to make sure it's valid. 4. It gets included in a new block. 5. The network reaches a consensus to add that block to the chain. And finally, 6. It's done. It's final. Maher now has his tokens, and that record is permanent.
So why go through all this trouble? Well, the power of doing it this way is just immense. This system creates trust between total strangers without a bank in sight. It allows for true digital ownership so you can actually prove you own a digital photo or a piece of music. It gives us a secure and transparent record for, well, anything of value. Imagine tracking a luxury bag from the factory to the store to know for sure it's real. And on top of all that, it can even run little automated programs called smart contracts, which are like vending machines for agreements.
So when you boil it all down, here's the takeaway. We've just walked through a system that literally manufactures trust using nothing more than math and code. It gets rid of the need for these powerful gatekeepers in our digital lives. So the real question, the one this leaves all of us with, is now that we have this powerful new tool for building trust, what are we going to build with it?